think what this project represents, at least initially, is a remarkable collaboration between the DAR and the botany department. So I think Dan Polhemus could get up and give this talk just as well as I could, in that we have spent many hours working the details of this thing out. And what I'd like to do today, or hit the high notes rather than give you all of the details, but what we are seeing is, what I'm going to talk about is the beginning of, I think, a joint effort to actually do more research and collaboration than we probably have had before. Would you agree, Dan? And that this is, I think, a new kind of community, and ultimately I hope that we could reach out to the communities that live on the Maui area, so Paikili area, that would be affected by some of the things that are going to be talked about. So before doing that, though, talking about this HCRI project, I'd like to give you a little update of where we stand with the nuisance algal bloom grant work that was 5 years of NOAA funding that preceded this study. This is our basis, probably the biggest grant in my lab activities, to document the impacts of the algal bloom and try to understand some of the biological and physical factors that might be driving the blooms of algae in this area. For a variety of reasons, we selected Hypnea muciformis, which blooms prolifically in the Kihei area, which is not the site of this study. This is over on the eastern side of the south coast of Maui. Those blooms have been persistent since the mid-1980s. So when I was first hired, I got a phone call from the mayor's office saying, what do we do with this stuff? Do we cut it up and throw it back in the water? You're supposed to say, ah, because that, of course, would just propagate this. It illustrated for me how little expertise there was on that island to understand the impacts of this algal bloom in the coastal areas. Clearly, the region in Kihei is under siege by this plant. The HCRI in 2003, I think it was, published an economic assessment that documented the cost of this bloom at $20 million a year in conservative costs associated with loss of rental income and decreases in property value. The county had obtained money from Senator Inouye as a means of mechanically cleaning those beaches, but very few studies actually looked at the health of those coasts, which are clearly at risk when you look at these kinds of biomass accumulations. This is not typical of a tropical ecosystem. It's clearly more of typical of a temperate ecosystem like a kelp forest in terms of the biomass productivity that's associated with it. The economic assessment was actually quite conveniently done, comparing condos that had been built in different locations, but by the same developer at about the same time. So they were very close to being equivalent, except for the quality of the coastline, this being the desirable one and this being the murky algae one. And so these types of studies really placed us on a map that is remarkable, and few data from elsewhere are available to document impacts of algal blooms in tropical reef regions. This is the modified potato picker that the county had purchased at about $200,000 to run up and down the beach to pick algae off and shake it a little bit so that the sand falls back in. You'll notice a significant berm in the background. That's the algal biomass that gets left on the beach because there are regulations that prohibit the removal of sand from the beach. So as soon as the alga gets stranded on the beach, it's coated with sand and it can't be removed from that area. So there's a vicious cycle of nutrients potentially going from the decomposition up here right into the water column, leading to a really murky, nasty environment. This is what it looks like in the water, not a place that any tourist would ever want to go swim. So the health of the coasts were really what were prompting that NOAA funding. And in some of our initial studies, we looked across the island and found that there are, in fact, 3 areas of persistent algal blooms on Maui that are very coincidentally located near injection wells. Injection wells there are at least 3 major ones that are run by the county. This is why we need the county to be part of the solution to this problem. These bloom areas are within a mile or less of the sites for these injection wells. But it remained unclear even after an earlier set of studies in the early 90s what role those nutrients from the injection wells might actually play in driving the blooms of algae. So from some of our earlier studies, we went along the coastline. This is work by Jen Smith, starting down here in Ahikinau in the healthy areas, and looked at a variety of water column nutrients. And you can see as you move up into the urban Kihei area, the nutrient in the water column level, just what you can quantify in the water column, is clearly elevated in the silicates and nitrates compared to what we see in the non-urban regions. Is this the nutrient source that's driving the algal blooms? These two panels in the center and to the right are stable isotope values that are determined from the tissues. This is one of the techniques that we developed. This stable isotope determination takes the tissue of a particular algae, dries it, grinds it, and then analyzes it for the flavor of nitrogen that's available. Now, if we take many of these same coastlines from Ahi'ikina all the way up into Kihei proper, you can see that, in fact, the signature of nitrogen at healthy, low, or not very urbanized areas, those are nitrogen values are low for the stable isotope signal, very close to oceanic conditions. As we move into urban areas, and especially in the plume that was determined for the injection well, the plume, it runs about 1.5 kilometers in width, moves right into the coastal area in this site at Halama. You can see that with that study, there's a slow, steady increase in the value, the numerical value for the stable isotope signal, so that we are, by the time we are sampling algae from the Halama Beach Park, ulva in green and hypnea in red, we are effectively looking at plants that are growing in straight sewage. So it's quite clear that we have a variety of sources or a variety of sites around Maui where nutrients are in excess and driving the algal blooms. Going to the points that Ivor made earlier about manipulating some aspects of these communities, like the herbivory pressures. Can we turn these factors in the physical and biological environment around as a way of helping to restore the conditions that would allow for corals to dominate? So the key factors that have generally easily observed in the shift from coral to algae are elevated nutrients, so we can check that one off. We have the introduction and spread of invasive algae. We can check that one off. Hypnea muciformis, for instance, is an alien species that was brought to Maui probably by the tugs as they moved things inter-island. Acanthophora is also another alga that is an alien species in that region. Where we have little information is in this over-harvesting of the coral reef herbivores. And we've got to find ways by manipulating this as our most likely parameter that is potentially something that can recover in a short period of time. We've got to explore this as a means for shifting that competitive balance back to coral dominance by providing an increased number of herbivores. So that's really what we're working towards with this year. Our outcomes, if we don't do anything, is little chance of improvement. In fact, the algae will spread and probably make a nearly continuous distribution as urbanization is increasing. There are 4 more developments that are going to be going in on the Gold Coast of the West Maui area, for instance. There are going to be increased degraded habitats, severely reduced environmental and economic values, becoming more and more a character of this island. It's bad enough what we've done to Oahu. We, I think, still have an opportunity through creative use of science and management to turn this around.